Hello, my dear friends and my beloved students. Here we are in another video, in another lesson, under the title of Areas of Compound Shapes in our book, which is Cambridge Lower Secondary Mathematics for the learners in grade 9. Alright, so in this section, basically we are dealing with like areas of compound shapes. You might ask me, what do you mean by compound shapes? So compound shapes are a kind of shape that originally or basically they consist of two or more shapes. So let's just work, for example, first of all on the work example, then we are going to go and jump to the exercises and we will solve just like the previous lessons, some of them, most of them, not all of them. We will leave some of them for you guys in order to practice by yourself and test yourself as well. So here it says, work out the shaded area of each compound shape. Give your answers correct to the third significant figure. All right. So here, our first shape that's like is shaded all consists of, it made up of like a semicircle and a rectangle. So first of all, I would love to name this one shape 1 and here shape 2. So the area A1 stand for the area of the semicircle and A2 stand for the area of the rectangle. Great. I hope that you can understand it. What was the area of a semicircle? In the previous video, we studied that the area of semicircle is the half of the area of a circle, because semicircle means half of a circle. So pi r squared over 2. So here, pi times like r squared. So what is r? R is here. So half of 9 is 4.5. So 4.5 squared times pi divided by 2. Okay, so let's consider 4.5. I will count pi. Remember, in our lessons we count pi as 3, approximately 3, in order to have nice calculation. So here we have 3 times 4.5 times 4.5 divided by 2. Perfect. So if we multiply here by 100 and that one, the denominator as well, by 100, this 100 will move this decimal point one place to right side, so it's going to become 3 times 45 times 45, and the denominator will become 200. So right now we got rid of the decimal point and we are just dealing with integers. So 45 times 45, let's just do it here. 45 times 45, so 5 times 5, 25, 5 here, 2 here, 5 times 4, 20, plus 2, 22. So 0, 4 times 5, 20, 0 here, 2 here, 4 times 4, 16, plus 2, 18. So we are gonna have 5, 2, 2 and 8, 10, 0, 1, and 2 here. So the answer is 2025. Then multiplied by 3, so we are going to get 3 times 5, 15, 5, 1 here, 3 times 2, 6 plus 1, 7, 3 times 0, 0, 3 times 2, 6. So here is the area divided, of course, by 200. So here is the area of the first shape when we count pi as 3. How about the area of the second shape? So in rectangle, we say that like length times width. So the length of our rectangle is 9 times the width is 3. So 3 times 9, 27. So the compound area, we can say AC, the compound area is equal to A1 plus A2. Instead of A1, we can write 6075 over 200 plus 27. The area of the second shape, which is a rectangle. So if you want to simplify this one, we can add them, we can equalize, take the common denominator, which is 200. So here it's going to become over 200. 200 divided by 201 times 675 plus 200 divided by 1, 200 multiplied by 27 multiplied by 27, well, it's gonna become 5,400. Well, if we add them, we are gonna get 5, 0 plus 7, 7, 4 plus 0, 4, and 5 plus 6, 11. So 11,475 over 200. So if we just divide this, do this division, we are going to get a result, of course, with decimal point. And then we will round it to the third significant figures. That is all about this question, and I'm pretty sure here we have got something. So look at the solution here. 27 for the area of the rectangle, and area of the shape B, which is the semicircle, is equal to 31.8, which if we do it here like 6,075 divided by 200, we are going to get something like close to this number. And then the total area is equal to the addition of these two. So I'm pretty sure it just rounded to the third significant figure, and it got like 78.5. So here, the area of the second shape is a circle. Okay, we have got a circle and a hole inside it. Like the hole is in the triangle shape. It's like a triangular shape. So we have to calculate the whole area of the circle and the area of the triangle. Then we have to take out the area of the triangle, because since it's not shaded, so we have to do subtraction. We have to subtract the area of the triangle from the area of the circle to get the total area. So the area of the triangle is like base multiplied by height divided by 2, or multiplied by 1 over 2. It's the same. So 4 times 7, 28, divided by 2, 14 centimeters square. And the area of the circle is equal to pi r square. So pi is, remember, in your calculator, just click on the pi bottom. So multiplied by 5 square, which is 25. So 25 multiplied by pi, it will give you like 78.5. I think I mixed this one by this number. So the previous total area was 58.8. Guys, remember that? And the shaded area here is equal to the area of the circle, which is 78.5, minus, as I already mentioned, the area of the triangle, which is 14. So 78.5 minus 14 will give us 64.5. Let's just do some questions by ourselves. So in compound shape, as I already told you, we have got like 2 shapes or sometimes more. So here in our example, copy and complete the workings to calculate the area of these compound shapes. Hopefully, it didn't mention to round it to the third or second or first significant figure. So here is the area of shape A. As you can see, since the sides are not the same, so it is a rectangle. 4 times 5, length is 5, width is 4. So 5 times 4, 20. And the area of shape B, again, we are dealing with a rectangle, but this time the length is 11 times the width is 2. So 2 times 11, 22. And the total area is 20 plus 22, so we are going to have 42 centimeters square. How about here in the shape B? So I would love to leave this shape B, because since they are the same, so I'm going to just leave this one and I will directly come to this here. We already solved the question regarding to this one, so you may just do it by yourself. Take a look at back this to this example, then I'm pretty sure it will be helpful for this one to solve this part C. But let's just deal with part D. So we have got subtraction because a small part of our circle is not shaded. So that shape that it is not shaded is in a rectangular shape. We have to calculate the whole area of the circle and the area of the rectangle, then subtract the area of the rectangle from the whole area of the circle. So first of all, the area of the rectangle, as you can see, it's length times width. So the length is 1.5 times 4 to 1.5 times 4. So it is going to give us 6. Go and calculate it. I'm pretty sure you are going to get the same thing. How about the area of the circle? So pi times r is 3. So 3 square is 9. 9 times pi, it's 9 pi. All right. Perfect. Which if you want to get the exact thing, we cannot get actually an exact amount, but 9 times pi, it's equal to like something like 28 almost. All right, maybe 28.2 or 3, or let's say anything, but we are going to count 28 because pi is approximately 3.14. If you multiply it by 9, we are going to get like something between 28 and 29. So let's consider 28. So the shaded area is the area of the circle, 28, minus the area of the rectangle, which is 6. So 28 minus 6, it's going to give us 22 centimeters square. So I will leave B and C, guys, for you in order to not make the video longer. How about the second question? The second question, as I already told you, compound shapes sometimes consist of 2 or more shapes. So based on that, here there are 2 shapes. Here there are again 2 shapes, but here there are 3 shapes. So I prefer to solve this one because we have like a different case that it consists of 3 shapes. So shape A, B, and C. So the total area, it says find each of these compound shapes, work out the missing length shown by a square, and the area of compound shape. So this one here. So first of all, we should find the missing length shown by this square. So here, as you can see, from here to here, it is 18, right? But here, 6 units of it is gone for this length. And for the width of this rectangle, 5 of it is also gone from here. So 5 and 6, 11. So 18 minus 11 will give us 7. So it means that distance is 7. So this length, let's say, it's 7. So for the other shapes, you can just use the same idea. For example, here is 11 from here to here. That part is 8. So 8 plus what is equal to 11? 8 plus 3 is therefore here is 3. And from here to here, it's 10. So here is 3. How much will remain for here? 7. How about here? So it's completely 14 from here to here. So 3 for here, 3 for here, 6. 14 minus 6. It will be 8. Well, it doesn't make sense, honestly, because here is here, from here to here is 3. So from here to here it is 3. And how much will remain for here? So 3 plus 3, 6. 6 minus 14, 8. While that length, logically doesn't make sense. It's almost the same with these two, so it cannot be it. But mathematically, it should be 8 in order to make 14. Perfect. So let's focus on our example here, part C. So in part C, we have area of A. So AA, it's equal to, since it is in rectangular shape, so the area of a rectangle is length times width. So the length is 5, the width is 11. 5 times 11, 55. How about the area of B? So again, we are dealing with a rectangle. Remember, the length is 7 and the width is 5. So 7 times 5, it is equal to 35. How about the area of shape C? It is again in rectangular shape. So the length is 6 times the width is 8. So 6 times 8, 48. Now the total area, let's say AT, which is the total area, is equal to 55 plus 35 plus 48. So 35 plus 55, it is equal to 90. 90 plus 48, it's equal to 138 centimeters square. That is the compound area of this shape. Great. How about here? For each of these compound shapes, work out an estimate of area of the shape. And the second thing that it asks about is the area of the shape correct to the 1 decimal place. So there are two ways, guys, here. Either we can estimate these measurements from the beginning before calculating the area of each shape, or just the second way, which is a little bit like harder, using these decimal numbers to find the areas of each shape individually. Then at the end, when we found out the total area, then estimate and round it to the first significant decimal place. Well, here, if you round this one 5.2 to the first decimal place, so here is 2. Since it is like so I'm going to use like the second way, because it says if the area of the shape correct to 1 decimal place. So first, an estimate of the area of the shape. Well, here this compound shape consists of a triangle and a rectangle. So shape A and shape B. Alright, so I will do it here in my paper. I wish that I could, okay, I will change it to 1 and 2. Alright, so A1 equals to, guys, like the area of a triangle is base times height. So the base is 7.4 times the height is 5.2 and divided by 2. If you do this calculation, I am pretty sure that we are gonna get like the multiplication of these two is 38.48 if you calculate it. I already calculated and I got it like this, 38.48. And if we divide it by 2, we are gonna get 19.24. So here is the result of the A1. How about A2? So in A2, we have length times width. So length is 7.4 and times the width is 3.9. So 7.4 times 3.9 is like 28.86 almost. Let's say centimeters square, and here is centimeters square. So the total area would be like the addition of A1 plus A2, which is 19.24 plus 28.86. So if we add these two, we are gonna get the total area. So 4 plus 6, 10, 0 here, 1 here. 1 plus 2, 3, 3 plus 8, 11, 1 here, and point, don't forget this point, 1 here, 1 here. 1 plus 9, 10, 10 plus 8, 18, 8 here, 1 will go here, 1 plus 1, 2, 2 plus 2, 4. So 48.1, so it's going to become 48.1 equal to 48.1. That is a result, that is the estimation for the area of the shape, and it is almost, let's say, almost equals to like 48 centimeter square. How about let's just do for one other shape. So here we have a square, because the shape, look, the size of the lengths are the same, so 2.68, 2.68. So first of all, try to find the area of this square, and then this semicircle. The semicircle is the the radius of the semicircle is 1.34, and you can use that for the radius. Here we have got the semicircle and the triangle. Here we have a semicircle, a big one, plus a small one. So that looks like interesting. Let's just do this one. And how many questions left here? So the questions regarding to subtraction, we will solve some of them. So here, let's just do D. Okay, for D, we have a big semicircle. So let's say shape 1 and shape 2. So shape 1 is like area A1 pi r squared divided by 2. So pi, just keep it, multiply by r. So the r is 28, guys. From here to here it is 28. Remember, for we are in the bigger semicircle. So 28 square and then divided by 2. All right? So the result is like almost, let's say approximately 1231.5. Okay, so here is the result of the area of the bigger semicircle, by the way, millimeter square. How about the area of the second one? So pi r square over 2. Again, pi is the same, but r, guys, here the radius of this smaller semicircle is half of this 28, which is 14. So 14 square over 2. So 14 square is like something 196 pi over 2 equals to like 307.8 approximately. So it has like endless endless like decimal numbers. That's why we are just taking the first decimal place. So the total area would be AT equals to A1 plus A2. So let's say 1231.5 plus 307.8. If we add them, 5 plus 8, 13, 3 here, 1 here, 1 plus 1, 2 plus 7, 9, 2 plus 3 plus 0, 3, 2 plus 3, 5, and 1 plus nothing, 1. So the result is 1539.3. That we can round it to the first decimal place, so it's going to be almost 1539. So we are going to round it down. All right. Here is the result of this question as well. So I will leave these two for you guys in order to do it by yourself. How about here? So here we are dealing with subtraction idea, because as you can see, like we have some compound shapes that one small part of it is not shaded. So I will go with part A, and I will solve A and C. Then I will leave B for you guys. So work out area of each shaded shape. I hope that you can see the paper and the questions, guys. Work out the area of each shaded compound shape. So the first one, we have got a big rectangle and a smaller one, just like a hole inside it. And we have to find the area of both of them and then subtract this one, the empty one, from the shaded one. So the shaded one, let's name it as 1 and here as the second one. So the A1 is length 8 times width, 8 times 5, 40. And A2 is the area of this one, which is again length times width, so 3 times 2, 6. So the AT, which is the total area, is 40 minus 6. So 40 minus 6 is equal to 34 centimeters square. I will leave V for you guys, then let's come to C. So the C is, A1 is the area of a circle and A2 is the area of the triangle. So A1 is, the radius is 8 millimeter, so pi r squared, not divided by 2 because it's a complete circle. So r is square is 64 times pi, which is almost something around 201, like almost approximately 201. How about A2? So A2 is a triangle. In our triangle, if you just take a look at it in this way, base is 9 millimeter and the height is 3. So according to the area of a triangle, it says that base times height divided by 2. So 9 times 3 over 2. So 3 times 9, 27, divided by 2, it's almost like 13.5. So AT, which is the total area, is 201 minus 13.5. So if you do this subtraction, well, 0 minus 5 impossible. Go to this one, make it 0, and this one will become 10. 10 minus 5, 5. 0 minus 3, we cannot. Go to this 0, go to this 2, make it 1, make it 10 here, and then this 9, then this 0 will become 10. So 10 minus 3 is 7. 9 minus 1, 8. 1 minus 0, 1. So it's equal to 187.5, guys. I don't know whether you are allowed to use calculator or not, but if you are allowed, so you can just do these calculations with your calculator. I have no calculator right now, that's why I just do the calculation by myself. Sometimes I might make some mistakes, so you may just fix it by yourself. The thing that it is important here is the process, how to find the solution. Perfect. Let's go to question 6. And Sophia draws these two shapes. Sophia makes this conjecture, okay? I think the two shaded areas are approximately the same size. Are they the same? We are not sure, so we have to find it out, right? How are we going to find it out? So we have to calculate the area of this one. That's the total area, and the total area of here. Then if they were equal, if they were the same, so Sophia is correct. If not, so you are just simply saying that she's not correct. So I will leave this question for you guys, but I will give you a tip that, like, you are gonna count, find the whole area of this square, 50.5 times 50.5, so you will get a number, and then 40, the area of this circle, so the diameter is given, half of the diameter is 7 square 49 times pi, you will get something. Subtract it from the area of the square, you will get a number, keep it. Then find the area of this circle, the bigger one, which is the radius is 8, so 8 squared 64 times pi, you will get a number, minus the area of the white circle. So the radius of this circle is 6, so 6 squared 36 times pi, again you are going to get a number, minus it, subtract it from the previous one, so you will get the total area. If they were the same, you are gonna say that Sophia is correct. If not, you will write the correct solution. There is an activity here. I hope guys you read it, and if you were interested, you may just do it and think like a mathematician. Just leave it for you. And then here we have got like two nice questions. I will make one of them as the last question of these videos because the questions are almost the same in this lesson. So they all are around like compound shape, either addition or subtraction. All right. So I will choose. It says Aaron draws these two shapes. The side length of the squares are the diameters of the circle and semicircles. Aaron makes this conjecture that I think the shaded area in shape B is greater than shaded area in shape A. What do you think? Explain your answer. Show your working that you do. So we are going to find out whether Aaron is correct or not. All right. So the shaded area, the area of the shaded area here. So the square, let's make the area of the square 1 and the area of the circle 2. So A1 is equal to 10 times 10. 10 times 10, how much is it? It's 100 centimeters square. How about A2? So the A2 is the area of a circle, which is like the radius is half of this diameter, half of this side, which is 5. So pi times 5 square, 25. So it's gonna give us like 25, which is almost like 78, let's say 78.5 maybe, or like it's about 78 or 78.5 or 79. So let's just count 78.5. So here the total area would be like 80 is equal to 100 minus 78.5, which is 21.5. Exactly 21.5. How about shape B? So in shape B we have got two semicircle, and again, so A1 is the area of the square, and here we have 2 and 3 shapes, 2 semicircles and 1 square. So A1 is equal to again 10 times 10, which is 100. How about A2, which is equal to A3? Both of them are equal because their diameters are equal. So we are going to say that 2 times the area of each, only one of them, which is pi r squared over 2. This one will kill this 2, and again it's equal to pi r squared, which is 78.5. We already got it. So the total area is equal to like 100 minus 78. So 78.5 and 100 minus 78.5 will give us 21.5. Again, so since they are the same, Aaron is correct, and here is our working. And I hope guys that you got benefit from the explanation for this section. In case if you have any question, try to share it in the comments. Take care, and try to subscribe and like the video. Thank you so much for listening and watching my video.